Example 1, we're going to solve, but we're going to solve by the echelon method. All right, so forget about elimination. You're going to think, well, why don't I just do elimination? It's very similar, okay? But I'm going to do the echelon method. So the key to echelon method is understanding that you need triangular form. And that's what I'll be looking for when I grade. Okay, when I grade this, I'll be looking for that triangular form. So what happens is, look at the term that's outside of the triangle. See that 3x? We need to eliminate that. So it's kind of like when we're doing elimination, kind of like that. We need to eliminate that. But what we have to do is we have to eliminate that 3x using this 2x. Okay? So what ends up happening is you have to think about the least common multiple of 2 and 3. Okay? People get least common multiple and greatest common factor mixed up. Least common multiple. Multiples of 2 are 2, 4, 6, 8, 10. Multiples of 3 are 3, 6, 9, 12, yada, yada, yada. The least common multiple is 6. So basically what you want to go through is you want to go through 6. You want to use some combination of row 1 and some combination of row 2 that's going to produce a 6. Okay? You're gonna have to turn one of them into a 6 and the other one into a 6. You're gonna have to subtract so that they equal 0. So basically think about this. If I said 3 times 2 and 2 times 3 and subtracted them, that's going to make my 6 into a 0, and that's what I need to do. Okay, this is the hard part, everybody. All right, if I want to cancel out that 3x, I've got to have a math problem that says 6 minus 6 is 0. Okay, you could do other common multiples. You could do like 12 minus 12 equals 0. It doesn't really matter, but the smaller one's going to be the easiest for your brain. I need 6 minus 6. So what's important is to come up with the rule that gets you to that 6 minus 6. Okay? So what you could do is say 2 row 2's minus 3 row 1's. Okay? All I'm trying to do is get 6 minus 6. And so what I've said here with that green rule right there is 2 of the 3's, that's 6, or 2 of the 3 x's is 6x, minus 3 of the 2 x's, that's going to be 6x minus 6x. Okay? That's what I want. That's what I want. So the top row that's completely inside of the triangle doesn't need to change. 2x plus 3y equals 12. Don't mess with the top row. The bottom row, we need to change that 3x, so we're going to apply this rule right now. Okay? So you would say 2 of these is 6x minus 3 of these is 6x. Okay? So you can put 0x there if you want, but you're probably going to want to leave that blank. Okay? That 0x, we might just leave that blank because it's not going to be there once I get my triangular form. But continue with that rule across the way. Negative, okay, we've got 2 of those. That's negative 8. Okay? That'll be 2 times negative 4y minus 3 times 3y. You want to try to do that in your head, but if you need to write it out, go for it. Or negative 8y minus 9y is negative 17y. Okay. Then we apply that same rule to the constant number at the end. 2 of these, so 2 times 1 minus 3 of these 12s. Do as much of that in your head as you're able. 2 minus 36 is negative 34. Okay, so a couple of things. First of all, we wouldn't need this 0x right here. But second of all, we've produced the triangle. And I will be looking for that. That's how I know you're doing echelon form, is if you've produced that triangular form right there. Okay. After that, it's pretty easy because you can just take that bottom row right there and solve. Divide by negative 17, you're going to get y equals 2. And then back substitution means you're going to plug in that 2 into the other equation. Plug it into that top equation, you're going to have 2x plus 3 times 2 equals 12. Do some of that in your head. Skip that step. That's going to be 6. 2x plus 6 equals 12. Subtract the 6, you get 2x equals 6. Divide by 2, you get x equals 3. So our solution, 3, 2. That took a really long time, but once you get the hang of it, it goes a lot faster. Okay? You just have to know what you're doing. So, next example. Keep in mind, we need this triangle. Okay? It's going to work by finding the LCM of 2 and negative 4. Okay? Or any common multiple, but LCM is usually the best. The least common multiple of 2 and negative 4, or 2 and 4, I guess, would be 4. Okay? The LCM is 4, however you want to think about it. So I need to make a statement that says 4 minus 4, or negative 4 plus 4 also works. I need to make 0. So what we would need to do is say 2 of these and this one. Okay? I could say, if I said 2 row 1s plus row 2, that would give me 2 times 2 plus negative 4 is 0. That's what I want. Okay, I'm trying to get rid of that negative 4x. I need a statement that says 4 minus 4 or negative 4 plus 4. Either way, give me 0. Okay, so again, the top row can just stay put. 2x minus 3y equals 6. But that bottom row I'm going to change according to this rule. Okay, according to this rule. And so remember, the rule was 2 row 1 plus row 2. So let's do that. 2 row 1s will be 2 times 2x plus negative 4x or 4x plus negative 4x is 0. So you can write 0x right there if you want to, but a lot of times you're just going to want to leave it blank. The only time you would need to leave it there is if you need something there. If there's nothing else there, you'd say 0. All right, so move on to the next. The rule says 2 of these row 1s, so that's 2 times negative 3y, plus the row 2, that's what the rule says. Uh-oh, see what's going to happen here? That's going to give you 0y. So that's kind of a weird result. And then you move on to the last one. It says 2 of the row 1 numbers, so 2 times 6, plus the row 2 number is 8. That's going to be 12 plus 8 is 20. Okay. So 0x plus 0y, you can't just delete them both, but what you could do is say that that's equal 0. Okay. And that it does two things. First of all, it messes up your triangle because you don't really have the triangle. If that's 0 there, you don't really have the triangular form. But more importantly, you've got a mathematical nonsense statement. 0 equals 20. You've seen that before. What does that generally imply? That means no solution. It's nonsense. That can't possibly work. That can't possibly be true. If you graphed those 2 lines, you would see 2 parallel lines, right? Because they're not going to cross. Okay. So this one. Triangular form means I need to get rid of that 4x. Look at your LCM, okay? The coefficient in the top is 1. So you're trying to find an LCM of 1 and 4. Well, that's just 4. So you need a statement that's going to give you 4 minus 4. 4 minus 4, okay? So if I did row 2 minus 4 row 1s, that would work. There are other ways of doing it. If you said 4 row 1 minus row 2, that would still work. As long as you produce 0, it's going to work. Or negative 4 plus 4. If you did 8 minus 8, there's a lot of different ways to do it. You just have to find one. Okay? So that's my rule. Top row inside the triangle doesn't change. Bottom row, I'm going to apply that rule. That rule says row 2 is 4x minus 4 of the row 1s. Well, we know that's going to be 0x. That was kind of the whole point of why I picked my rule in the first place. So then we do the rule again. We've got row 2 is 4y minus 4 times row 1. Ooh, that's going to be 0y again. So it looks like it's going to be no solution again, right? But keep going. The rule says row 2 is 40 minus 4 times the 10. Oh, crap, that's going to be 0 also. So if you think about it, that bottom row is going to say 0 equals 0. So I'm just going to rewrite this. X plus y equals 10 on the top and 0 equals 0 on the bottom. Now, again, it kind of messes up my triangle because if that 0 is there, there's nothing there, all right? But also, we've got that statement that's not nonsense. It's not nonsense, but in the past, what have we always said when you got a 0 equals 0? Do you remember? That's where we said many solutions. In Algebra 1 class, that's where we said many solutions, okay? Now, that was okay for Algebra 1 class, but that's not going to be okay. That's not going to be good enough here, okay? There's going to be many solutions, but we can be more specific than that. It's not just any number. It's not like you can just say all real numbers. It won't be everything that works. There's a certain pattern. And that's where this concept of a parameter comes in. All right, a parameter is when you use a variable to help represent those many solutions. So think about it. Think about it. We've got this equation right here, x plus y equals 10. And that is certainly true. So all of our solutions are going to have to fit in that equation. So you should be able to think of some examples. For instance, if x was 1 and y was 9, those two numbers add up to 10, right? So that would be one solution, one of the many solutions, okay? You can think of more. Let's say x is 5, y must be 5. If x was 12, y must be negative 2. You could do fractions, you could do decimals. There's a lot of solutions. There's a lot of things that you could do. It would take us forever to name them all, and we'd never get there, okay? We would never get them all. But what a parameter does is a parameter is going to use a variable to represent part of that solution, okay? I want my answer to look like an XY point. It's nice when it's numbers like 3, 2 or something. That's one solution. But we have many solutions. We're going to represent that like this, okay? Typically what you do is take the last variable. The last variable here is y. And all you need to do is represent that variable in terms of the other variable. Okay? So think about that. We've got this equation. If I solve for the y variable, y is going to equal 10 minus x. You could say negative x plus 10, but there's no point in being slope-intercept form. We can say 10 minus x, whichever is easier. And so all we're going to do is put that 10 minus x in the place where the y was going. So every one of my solutions has the form x number, comma, 10 minus x. And you can plug it in and see if it works. If I plug in 14 and then the y part should be 10 minus 14, which is negative 4. And yeah, that worked because those numbers add up to 10, right? Okay, so the answer was many solutions, but specifically we can represent those many solutions using a parameter like this.